All right, so today we're going to review basic probability. Probability is a measure of how likely something is to happen, and you calculate it quickly in its easiest sense by finding how many ways there are to get what you want and dividing it by the total amount of things that can happen. That's known as the sample space, the total amount of things that can happen. Probabilities. If something's never, ever, 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 ever going to happen, then that probability is 0. And if it's always for sure going to happen, then that probability is 1. So the smallest probability is 0. The largest probability is 1. If you write those numbers as percents, that would be 0% to 100%. You never need to write percents in your answers for me. You can always leave your answers as fractions or decimals in whatever form they are. All right, so let's try some examples. A jar contains 32 red marbles and 28 blue marbles. You randomly pick a marble, find the probability of a red. Okay? Well, if I want the probability of a red, I need to know how many reds there are. I need want over total. So I want red. There's 32 of those. And I need to know my total. Well, if there's 32 red plus 28 blue, that makes 60 marbles altogether. So 32 out of 60 is my probability. In order to compare that easily, I would want to simplify that fraction. So on my Casio, I would use my fraction key, 32 ABC 60, and then hit enter and see what it simplifies to. On my TI, I don't have a fraction button, so I type 32 divided by 60. And then I press the math button. And number 1 says fraction, so I press number 1 there. And so I'll have 32 divided by 60 equals fraction. And I'll hit enter, and it'll tell me that it is 8 divided by 15. That is the simplest form, fraction. Okay, let's try a different one. Let's see, what if we want to do the probability that it is not red? Okay, probability that it is not red. Well, that would be every other color except for red, which there happens to just be 28 blue, so there's 28 ways to not get red. Total is still 60, so 28 out of 60 again. If I simplify that fraction, that's 7/15. All right, so a new situation here. A letter in the word restore is selected at random. Find the probability that the E is chosen. So again, probability is number of ways to get what we want. So how many E's are there? 2. Out of total. Total in this case would be how many letters are in the word. Rest plus 3 more. 7. 7 letters. 2/7 doesn't simplify, so that would be the end there. The probability of choosing a vowel. Vowels, remember, are A, E, I, O, and U, so we want to count how many of those letters are in the word. So our 2 E's plus an O, so 3 vowels out of the total, 7. Okay, something that's written as a complement. Not T. Anything but a T will work. Okay, so there's 1 T. We know there's 7 letters, so 7 minus 1 leaves 6 out of 7. Sometimes the fastest way to count what you need is just by subtracting it from the total. And then what about the probability that we get an R or an E? So there's 1 R. There's 2 E's, so R or an E, that would be 3 out of total 7. Okay, And one more common example here. 2 dice are rolled. Find these following probabilities. When you roll 2 dice, there are 6 things that can happen on one dice, and there's 6 things that can happen on the other one. In this image, they are color-coded. What happens on the red one versus what happens on the white one, so you can see. You can get double ones, or you can get a 2 first, a 1 second, a 3 first, a 1 second, or you could get a 1 first, a 2 second. Those actually count as different things. So there's 36 things. 6 things on the first die times 6 things on the second die. Counting principle there, 6 times 6 equals 36 outcomes. Here is a chart of the 36 outcomes for you to visualize. So what is the probability that if you roll these 2 dice, that you would get a sum of 4? Your 2 dice added together would equal 4. So if we think about it in our head, we can think, oh, okay, I could get a 2 and a 2. That's a 4. There's also a 3 and a 1, or the reverse dice, 1 and 3. There's 4 pairs of dice that would total up to a total of 4. So there's 3 things to get what I want out of 36 total. And if I simplify that fraction, that's 1/12. Okay, what about the sum of at least 9? At least. That means 9 or more. So that means 9 or 10 or 11 or 12, which is, of course, the biggest you can get when you total up the double sixes on your die. So we need to count the ones that total up to 9 or 10 or 11 or 12, because those are all things that get us what we want. So that's going to be this corner of the chart. 6 and 3 is 9. 5 and 4 is 9. 4 and 5, 3 and 6. They're all 9s. So there's 4 9s. 6 and 4, 4 and 6, 5 and 5 are all 10s. 6 and 5, 5 and 6 are 11s. 6 and 6 is 12. So there's 4, 7, 8, 9, 10 ways to get what I want out of 36 total, which would be 5/18 if we simplify. And then lastly, the probability of not getting doubles. Now this is one where there's a lot more that are not doubles than there are doubles. So we might want to think of this as the complement. The doubles are right here in the middle: 1 and 1, 2 and 2, 3 and 3, 4 and 4, 5 and 5, 6 and 6. There are 6 doubles. So that means we can subtract, right? From everything, there's 36. So there's 36, take away 6, not doubles, out of 36 total. So this would be 30 out of 36, which if we simplify is 5/6. So that was one where we would use the complement, because there's a whole lot less doubles than there are not doubles. So we find what's easier to find, doubles, subtract it from the total to get the opposite. Okay, if you have questions, ask in class.